Hi, Scott. Good evening.
Hi,
Good
hi,
morning.
Sridhar. Sridhar. Yeah. Good morning. Good morning. It's heavily raining outside.
In Vizag?
Yeah, it's raining heavily.
Ah, it rained here last 2 days, but not today.
Yeah.
Hi, Ram. You muted, Ram.
I need to go back to ID training. Can I do a fellowship?
I think Paul is on the line, so if we can share the screen with him, he can set up his slides.
Hello.
Hi, Paul.
Good evening. How's the
Good
lighting?
evening.
You guys?
A little bit more light could help.
Yeah.
Yeah, we can hear you well. Yeah, we can see you well now. That's
Yeah,
good.
that's better, right?
Yeah.
Hello,
Do you
Dr.
have
Kelly.
Hi, how are you guys? How you doing?
Very good.
You look
Good
relaxed.
evening, Dr. Yeah. Good evening, Dr. Kelly.
Good evening. How are you? Well, good
I'm
morning.
good.
Good
Thank
morning
you.
to you. Yeah.
Good morning to me. Thank you. Thank you.
How are you guys doing? Holding up
Yeah.
okay?
Good. Yeah. It's cool now over here.
A little better, right?
It looks
Yeah.
Yeah.
strong.
Paul, you have control of the screen yet or no?
Let me see. Do screen share. Let's see. I don't see the option for.
Sudhakar,
Hello.
I think you froze, Paul.
Yeah. Now it's. I can see you guys.
Okay.
Tablet.
Is Paul co-host Sudhakar?
I'm just asking him to co-host him. Yeah.
Okay. Yeah, you muted, Paul, but we're waiting for you to get screen share.
Oh, here now I have screen share. Okay.
Okay.
Yeah. Yep.
Yep, we're good.
Good to go. Yeah.
Yeah. Yeah, we can see you.
Yeah. Let me just minimize this. Okay. You guys want to watch?
You said your parents are going to join us, right?
Yeah, they're sitting right next to me, actually.
Okay.
Good evening.
Hi, good evening. How are you?
They're
And
like,
now I know Paul will behave, so I don't have to worry about him. I can log on.
I said they'll be.
Otherwise, he would have been quite quiet.
They would be better to look at than me.
Paul's mom is my colleague, Sudhakar, so she's also a physician. Yeah.
Okay. Dr. Chilibar, it's so great to see/hear you.
And yeah, it's nice to hear you too.
I honestly, I think you did such a wonderful job, honestly. It's last year was hard. We'll leave it at that, right?
Yes. Yeah.
It's good to be on the other side of it, right?
For now.
Yeah, definitely. Actually, yesterday was our first day when we had no COVID patients in the
Yeah.
hospital.
Yes, Paul came home and told us. It's
Yeah.
wonderful.
But it was short-lived. Today we had one.
Yeah. I mean, I don't think. I think
Yeah.
by the end of this lecture, we won't be feeling
You
assured.
won't be feeling so positive,
Yeah.
right?
You read more and more about it.
It's true. Technology is pretty amazing, right? Here we are
Yeah.
talking to people on the other side of the planet. Seriously.
I think where in Visakhapatnam, where Paul is giving the talk, numbers have gone down quite a bit, I think, right? Paul, Sudhakar, the numbers are down, right?
Where? Yeah, in India or?
Yeah, in India.
Yeah, they are. Yeah.
That's yeah.
And I
that's
saw,
the
I think
news.
I saw like 6% of the population was vaccinated though. It's still pretty low.
Yeah.
And,
No, I think they did a substantially more this week, I think.
Yeah.
Nearly, I think, first dose, a lot more people got it, I think up to 80% or so.
Are
Which is
we sending any vaccines to India or?
I think we are. Yeah, I thought we were.
We are, but I don't think they've got the first shipment yet.
Mm.
Such a small number, I guess, and people need to
Yeah.
get it, yes,
Yeah.
yeah. There is
India is
that.
beginning to rev up their manufacturing. I think they sorted
Yes.
because they can do large doses soon.
Also, there's this whole puzzle was for bigger kids than me. This is like this big mountain. So we get to go in the house. I can't do it.
Did you do that?
Saw it on the train.
He's right here. I can drive on the bus, but they're not. You can just go.
How is that organized? Like, is it through?
This is med school.
That's not.
So polite to right? I just think it's great.
Never Because I only go to the zoo. Yeah. There's ones and big ones, there's big horses.
Spring plus 61.
You know, I like on walking, that makes you go up and down. Down. Yes, you just go up and down, up and down.
She's going.
Yeah, she just there's a house around which How many people are they expecting now?
Shall we start, Sridhar?
Yeah, whenever you're ready.
Yeah, yeah.
Paul, you ready, right? Paul, you're muted, I think.
Yeah, you had muted me.
Yeah.
Yeah.
You didn't like my
yeah.
ambient breathing. Yeah, I'm ready.
Okay.
Yeah. Good morning, friends who are here in India, and good evening to all those who are from USA. And it's 11 months that we have started this weekly webinars, and this is the 77th episode. And over this period, we had 2 waves, and we are getting ready for the 3rd wave as well. And our webinars keep continuing with the latest that we need to know. And as the numbers are coming down and we're gearing up for the 3rd wave, we've been discussing on the variants. And last week we had a beautiful talk by Dr. Sridhar Chilamuri on the determinants of the 3rd wave and how to prevent it. And now we are talking about the variants, the vaccine and the vaccine escape, so on and so forth. Subsequently, we will be talking a lot on the post-COVID sequelae as well. So taking all these into consideration, this particular forum has gained a lot of popularity, and people are really looking forward for the weekend to listen to the experts. And I'm very glad that Dr. Sridhar Chilamuri and Dr. Karam Rammohan has taken this on their shoulders to carry this forward. And we have an expert in the infectious diseases, Dr. Paul Kelly, will be talking today. I'll hand over the proceedings to Dr. Sridhar Chilamuri to moderate this session after introducing Dr. Paul Kelly. Dr. Sridhar, please.
Yeah, thank you, and good evening, all of you. It's a pleasure to introduce one of the colleagues of mine who I admire most for many reasons. Paul Kelly trained both in the United States as well as in New Zealand. He's a specialist in infectious disease. He is the medical director of Bronx Care Travel Medicine, where they actually prepare patients for international travel, so he has expertise in it. More importantly, Paul is diagnosed the first COVID patient at my hospital. He was there right up front from the very beginning, seeing the disease as it evolved, intricately involved in the development of protocols and managing many patients, including several colleagues of ours who were sick themselves. Paul has seen it all and has taken us this far, so I asked him to come back and prepare us as well as you for the next wave of whatever that's in store for us. So Paul, you can go ahead and start.
Well, thank you so much for the honored introduction, and good morning to everyone. And again, I'm honored and delighted to speak to you once again on this topic, which I find quite fascinating, and I think the majority of you do as well. I'm also happy to know that things are settled for now for you guys to catch your breath. I know it must have been quite dire and harrowing, to witness all that you did. And even though I'll be talking a lot about the Delta, I know you guys have firsthand experience more than I do with that. So I do appreciate that, and certainly welcome your input after this discussion. So let's just get started. I just saw this recently in the train, and I thought it was one of the good, advertisements in New York City for vaccination. And, it's going to be a key theme to how we can conquer this So some of these slides you had seen before when I spoke to you guys in April, but there were some things I wanted to just re-emphasize again because it's quite important to understanding the variants and how this virus is evolving. And as we had discussed before, the SARS-CoV-2, COVID-19 is an RNA virus, so it's up here with a quite high mutation rate, just like HIV or Hep C. So it essentially mutates quite readily and quite frequently. And what that predisposes this virus to do is to actually change quite dramatically over time. Most of the time, the mutations are pretty benign and they don't change the activity or the expression of the virus. But if you allow it to do that over hundreds of thousands of times, eventually the mutation will result in quite a significant change in functionality for the virus. And this is what is responsible for the development of the variants that we're seeing from this virus. So that's a key factor to understand. And the location, as you all know, and just to review this, is basically at the spike protein at the edge of the virus. And so the receptor binding domain of the spike protein will change with these mutations. And so when it changes dramatically enough, it can alter both the virulence of the virus and also its ability to evade some of the polyclonal immunity, meaning natural immunity and vaccine-induced immunity that that we see. So the story does begin back in, this is now 2020, not 2021, but back in January of 2020, where the original parent virus, the D614, essentially started to evolve out of China and over through Europe. And then, as we had mentioned before, quite quickly, as you can see here, by beginning of April, a new variant, the 614G, took hold. And what we had discussed before is by the end of mid-spring, end of the spring of 2020, the 614G took over as the predominant virus from the parent virus. And it has essentially demonstrated very higher amounts of replication and binding in the human respiratory cells, as well as much higher viral loads, as this diagram shows. So already the variant was starting to become more infectious. Now, here's a summary of all the variants, and we had discussed most of these before, but I decided to sort of put them all together now because as of June 1st, the WHO has actually now assigned all these variants letters from the Greek alphabet. So just to orient yourselves again, here we have the Alpha variant, which is the sort of the first big variant to evolve, which is the UK variant, the B117. Now we have the South African, or the 351, is called Beta. And then we have the P1, or the Brazilian variant, as the Gamma. And some of the key mutations here, you can see they sort of retain the 501Y. But really what I want you to remember, and what we had discussed last time, was this 484K, which is actually does have the ability to evade some of the monoclonal antibodies and the body's innate immunity, immunity from natural infection. Here we have the California variant, which we touched upon as well, has been assigned as Epsilon. And the key here is that it does have this L452R, which also is quite adept at evading the immune system and especially the monoclonal antibodies, leading to resistance. Here's the New York, the New York variant that evolved straight out of New York City, which is now called the Iota. And you can notice here again the 484. Now, initially what we had said was that there was the double mutant, where you had two mutations from Gamma and Epsilon that actually combined and evolved in India as the B1617, very much known to you guys as the Delta variant. And you can see here the two mutations that are combined, which is why it was called the double mutant, are the SL452R from the California and the E484, but it's not a K. There was a point mutation to a Q, which basically is unknown at the point if it really has made it, quite different. But as we will discuss, the Delta variant is certainly much more efficacious as a virus, as far as its replication. So where do we stand now as far as the variants? This is a nice map taken from CDC. Actually, they really updated their surveillance. So you can see here, this is the Alpha, the UK variant that we were seeing. and verified in 167 countries, pretty ubiquitous, but I think will soon become outpopulated, outdone by the Delta variant. Here we have the Beta, the 1351 out of South Africa, which has also taken a nice hold over the world. Here's the Brazilian Gamma variant that still has taken some hold mostly in South America, but really hasn't become quite as ubiquitous as the other variants. And here we have quite rapidly the Delta variant has overcome a lot of countries in the world and will probably soon take over as the predominant variant. Here we have it as of this week, 90 countries have verified. So just to zoom into the United States, as of July 7th, the Delta variant has now been become the dominant variant strain in the United States. Previously, the UK or the Alpha was supposed to be the predominant variant, but now it's the Delta, as accounting for 51.7% of the new COVID-19 cases in the United States. And it was only about 30% about 2 weeks before that. So you can quite see it's almost not quite doubled, but it almost has doubled in that 2-week period. Where the distribution is, you can see here is a dark orange, mostly in the Midwest range of the United States, but certainly will probably start taking over in the Northeast, and I think in the South as well, for political reasons. Zooming into New York City, we actually we're seeing the IOTA, the 526, the variant, the New York City variant, was actually becoming predominant. But now, as you can see here in the last 4 weeks, it's actually fallen to 4th place. And you have a tie between Alpha and Delta. But now, as I zoom into the most recent data, as of June 26th, you can see here the Delta variant is accounting for 45% of the virus is isolated and sequenced in New York City, versus about a quarter of the Alpha, which is the UK. So you can see quite dramatically and quite quickly, this Delta variant has taken over and will become the predominant variant, certainly in the United States and in New York City. So what are the concerns of the variants? So the main categories that I separated out was transmissibility, severity of illness, and vaccine efficacy. So regarding transmissibility, this is what we had seen with the 614G. You had some changes in the spike protein, and it resulted in increased replication and viral shedding, longer levels of contagiousness with the increased binding to the respiratory cells, increased infectivity. And what we did see, the data has shown, which I referenced below, that the Alpha strain, the UK variant, was 50% more transmissible. Now we have data that the Delta, which the WHO has actually named the fastest and fittest variant of all of the virus, is actually 55%, and some figures quote at 60% more infectious than the Alpha. So that's 105 to 110% more infectious than the parent SARS-CoV-2 that we saw, in the beginning of January of 2020. So we have quite a high transmissibility with these variants, especially now with the Delta variant. Okay. So the R0 for the Delta is actually, for every one person, they will infect 3.5 to 4 people, which compared to the Alpha was about 2.5 people. So you can see here it's almost doubled as far as the R0 for infectiousness through other people. And regarding severity of illness, we had spoken about this before. There wasn't much data at that time, but the Alpha did show, there was data out of the UK that there was an increased risk of death, especially in the ages greater than 70 years old, that showed a higher rate of hospitalization and risk of death. And just recently, which we'll go into, out of the Scotland, which has about 95% of the virus isolated in sequences, Delta, showed that there is an increased rate of hospitalization, and it's actually double the rate of the Alpha, which is the UK variant. And we'll go into that at this moment. So basically, this was just published June 26th, so pretty recently. And it was out of Scotland, and they're evaluating the Delta variant of concern. And they looked at the time periods between April to June of 2021. And of note, the predominant sequence of virus from the periods of April through May 28th, where 97% of the viruses sequenced were the Delta variant. S gene positive just is a way that when they sequence it, they know that their spike protein gene is positive. If it's S gene negative, that usually is a deletion, which is which basically is what you would see with the Alpha or the UK variant, where they have a S gene deletion. So when they knew it was S gene positive, they knew it was from the Delta. Of those cases, 70% of COVID positive cases of infection had no underlying comorbidity. So it's not hospitalization, but this is infection. So 70% didn't have any underlying comorbidities who were infected. The major key here between Alpha and Delta is that the number admitted to hospital, as you can see here, the rate was almost double to Alpha, 62 per 100 person years versus 36. Not quite double, but almost. And the majority of patients who were hospitalized from Delta were actually did have a significant amount of comorbidities. Okay. As far as symptoms with the Delta, there's been surveys from the UK. They're very good about surveying the symptoms that are occurring, and they have a national database which physicians can log into, and then everyone can look at it. And basically, it seems that cough and anosmia are less common. And I'm curious to hear the thoughts of you guys' personal experience with symptoms there. And it seems like the majority of symptoms patients reported are headache, rhinorrhea, very non-specific viral syndrome sort of symptoms, but there seems to be some pattern that's emerging with the symptomatology for Delta. Okay, so getting back to the third arm of this is vaccine efficacy. And we touched on this last time as well, and that the majority of vaccines, especially the mRNA, are quite effective against the majority of variants that we see. And I will summarize this later, but the mRNAs of Pfizer and Moderna seem to be the best. The AstraZeneca, Covishield, and Johnson & Johnson sort of fall into second place. And then I think the Sinovac would probably be, much less. We think it's not as effective. Now, this is also data that came out of the same study out of Scotland. And what they saw was that the risk of infection, and that was basically 14 days after dose 2 of the 2-dose series. So that would be Pfizer or Moderna, but mostly they were Pfizer. Is that if they got 2 doses of Pfizer, they were 92% protected against Alpha, but about 79% protected against Delta from getting infection. Whereas with the AstraZeneca, which would be equivalent to the Covishield that you guys have there, after 2 doses, Alpha was about 73% prevented versus 60% with Delta. So much lower with Delta in both vaccines. So certainly what you're seeing here is a decreased vaccine efficacy against this variant. It's not zero, but it's definitely much lower. As far as hospitalizations go, it seemed that they were pretty much the same. They were low, so meaning not many were hospitalized, but they didn't have the sufficient numbers to compare between the 2 vaccines. But overall, the hospitalization rate was low as long as you were actually vaccinated with both doses. Okay. Now, just a summary of overall vaccine efficacy for the variants. As you can see here, with the original virus, the majority of the Pfizer, Moderna, the mRNA vaccines are very effective. The Johnson & Johnson 1 dose, AstraZeneca about 3/4, and the Sinovac is the least. With the Alpha, for the most part, retained the efficacy. But then when you start getting into the South African, Brazilian, you start to see decreased efficacy, especially with Johnson & Johnson, falls to the 60 range. With AstraZeneca, that one study we talked about last time, they showed only 10% were actually protected with the South African variant. Sinovac, also not effective. And then again, here, when we go to the Delta, reduced efficacy, as we just mentioned. And, right now we have the data that just came out recently with AstraZeneca, so it's about 60% versus 80% for the mRNAs. Okay, so those are the 2 major numbers to sort of remember. So what about monoclonal antibody therapy? And, this is something we've been using in the United States, mostly in the outpatient. And I know you guys haven't been using it as much, but as of June 17th, the Department of Health issued a statement that essentially the Beta, which is the South African, and Gamma, which is the Brazilian variants, are actually resistant to dual therapy. We were supposed to, it was basically giving double therapy with the monoclonal antibodies of bamlanivimab and etesivimab. these variants are resistant to these two combinations of monoclonal therapies, and essentially recommended to use either the Regeneron or sotrovimab, which is a third monoclonal antibody. Okay, so you're already seeing resistance. And again, you remember both of these variants shared that mutation, the 484K, which is also present, excuse me, in the New York variant, which was also resistant to these monoclonal antibodies, and the Delta. This was just hot off the presses. It came out 2 days ago, July 8th, published in Nature. And it was basically they used serum from a traveler who went from India to France and who had Delta, and they used his serum and used the virus, and they compared it to sera from other patients with various, exposures, prior infections, etc. And so they compared his sera to other convalescent patients, and these were patients who had been sick 12 months after symptoms. And what they found is that their antibodies, from their natural infection, not from vaccines, they were 4-fold less potent against Delta compared to Alpha. So you already have your sort of, your innate immunity generated from natural infection is much less effective against Delta compared to Alpha. And then once they started using sera from individuals who received 1 dose of the Pfizer, which is mRNA, or AstraZeneca, it was basically nil. There was barely any inhibition of Delta. So 1 dose is basically useless against Delta. So you have to complete both doses. Okay, so 1 dose was essentially ineffective in inhibiting Delta with the serum from these individuals based on this study. Administration of the 2 doses generated a neutralizing response in 95%. So there you have that second dose, and you're able to generate the 95% efficacy of antibodies. However, the actual titers were 3 to 5-fold lower against Delta than Alpha. So you are generating the immune response, but the actual measurable titers are still lower against Delta, which is still actually expected, but is of concern, with the rate of decay that it's hard to predict with each individual who's vaccinated, but if someone doesn't generate as much antibodies as someone else, someone who's immunosuppressed, let's say, or on immunosuppression, and you have very low antibody titers to begin with, they're going to become susceptible to Delta despite vaccination much faster than the other variants. What about Delta against some of the monoclonal antibodies? So they looked at these 4, and basically you can see here the dark orange, or the only one that's orange there, is Delta. And you can see here versus bamlanivimab, there was essentially virtually nil neutralization. So resistance to bamlanivimab, okay? Then you have, which we didn't see with the others, but you see with etesevimab, carasivimab, and imdivimab, there was actually activity, but then you see here, so it seems to change where you have the beta, which is the South African variant. There's really no activity, in which we had just mentioned there was resistance, and there's decreased activity with carasivimab. It seems like imdivimab had the best activity against all those variants. So it seems to fluctuate and change depending on the variant here as well. And the Delta spread associated with basically escape antibodies, so that the receptor binding domains and the spikes are not able to be targeted. So the antibodies don't bind. So leaving Delta, now there's Delta plus. So an evolution of a variant on top of a variant. And so it's been named Delta plus. It's actually the B617.2.1, or also AY.1. This was detected in India, excuse me, in February of this year. And there's an extra mutation, the K417N. It's probably more than 200 cases, but as far as now, there's 200 cases that have been identified in 11 countries, so it's already spread. Seems that it's only responsible for 1 death in India, probably more. And as far as the government there that I saw, and again, I'd love to hear what you guys are hearing on the ground there, but from what I could see, that there's, which is not a surprise, that there's increased transmissibility, there's stronger binding of this variant to respiratory cells, and reduction in antibody response. So, we would expect this would be either virtually similar to Delta, or perhaps even more, more potent than Delta. We don't yet know the effect on vaccine efficacy, and that needs to be studied, as soon as possible. So leaving Delta, we have another variant that's evolving in South America. It's called the Lambda variant, C.37. This one actually also evolved in Peru in December of 2020. Not so widespread, but predominantly in South America, 29 countries. It accounts for 81% of the variants in Peru, 31% in Chile. At the moment, though, it's unclear whether it's more transmissible, if there's more severe disease, or if it has any decrease in vaccine efficacy. So more data, excuse me, has to be collected on this variant as it evolves. There was some study done in Peru where they looked at the antibodies that were generated by the vaccine. So that's the mRNAs of Pfizer, Moderna, and also Coronavac, which seemed to be less powerful against Lambda than the original strain, but they were still able to neutralize the virus. So again, someone who has a very intact immune system, they're going to have the amounts of neutralizing antibodies. However, the rate of decay being as it is and sort of fluctuating with each individual, and certainly someone who has a weak immune system to begin with, their level of neutralizing antibodies will be much lower. So basically, what are the concerns in summary for the variants? And we touched upon all of these, but really it's what we have to keep an eye on. And essentially it's transmissibility, which we're seeing as the variants evolve, they're just becoming more and more transmissible, especially with the Delta. The virulence definitely is increasing. So basically the virus, if you look at the trend, is feeling this pressure, it's feeling the selection pressure, whether or not it's from vaccination or it's basically because it's allowed to mutate and sort of continue to propagate readily. It's able to, just like a bacteria that's exposed to antibiotics, it's not completely killed. It's just, exposed to it enough so that there's selection pressure for the mutations. So that the virus is becoming to, is evolving the ability to escape our immunity, whether it's, generated from vaccines or from natural infection or both. So this is really, really a concern, which is why leaving this virus to transmit unchecked is so dangerous. And that's exactly what we're seeing the effects of. Vaccine efficacy, again, the most important thing to combat this is vaccination. It's actually the only thing I think we have. The monoclonal antibodies, obviously not realistic for the world. This has to be a world effort. And so as you can see here, where I use the sort of coarse analogy of urinating in a public pool, where if someone does it in one corner, it still might, affect everyone else. Where if we're not vaccinating and taking care of this as the world as a whole, essentially it's going to affect everyone, as which we see quite rarely with a lot of these variants. And so with that down, I don't want to keep you guys too down. It's so early in the morning for you, but there is a spark of hope, and that is vaccination. And that's something we're going to have to keep pushing. I know you guys are ramping up your vaccinations as you have a lull in your waves. So hopefully it's able to increase for you, so you don't see the horror that you did, and that the rest of the world can continue to sort of see things as they go and not politicize things and sort of think about the world as a whole and not the individual. And that ends the talk.
Yeah. So we'll open up for questions, Paul, but let me ask you a few questions. I think the big worry in India is that the emergence of a third wave that's on their way. How often do these waves come, and how long are you seeing the development of a mutation or a variant, and then that variant taking over the dominant infections? I mean, what is the average time that we're looking?
It's a good question, because I don't think we've ever seen that. If you look at history and you look at the waves of most of them being influenza pandemics, is that they lasted for 1 to 2 years, but they didn't hit so many waves. And I really think this is quite different because, as I showed you in that first slide, the virus mutates so quickly and so much that it's exponential, and the log of mutations that can result in a variant of concern is much higher than something like influenza. So I think we're going to unfortunately see more waves. And so I think it's unprecedented, to be honest. I mean, I'm thinking about all the pandemics in history, most of them were either plague or influenza. And, they really didn't have this degree of variance, for lack of a better term. They hit, and maybe they came back again, and that was it. But this is a continued third, fourth wave of infections. Is really, to my knowledge, unprecedented as far as the viruses go. So, I think the rate is a lot faster than we can keep up with. I mean, I think even our own New York City Department of Health, they're only doing spot checks of sequencing. They're not sequencing every single virus. So by the time they're seeing, oh, it's 46% of Delta, I think it's quite higher. And I know, just personally speaking with colleagues this week, we're all sort of like seeing this and hearing this happening, but we're like, why is it so quiet? Where is it? So there's sort of like this, impending doom, although it doesn't feel as bad as it did of spring last year, but it's something is missing that we're not seeing at the moment. But I think we're always playing catch up, until you're just sequencing these viruses as fast as you can, and obviously stopping it from replicating. It's going to continue to go, and it's quite fast. I mean, I don't know a number, but I think you see every few months these variants are evolving.
Sudhakar, you have anything?
Yeah, Ram Mohan has a question, it appears. He raised his hand. Ram Mohan.
Ram, you have to unmute your microphone. Ram, unmute your microphone. No, you have to unmute your microphone, Ram.
Now I can. Thank you. I was going to ask, he used the words, Paul, impending doom. If the vaccination rate in India does not pick up quickly in the next 3 or 4 or 6 weeks, because apparently I heard today the government is relaxing the lockdown regulations, allowing more congregation and people meeting each other. And past experience tells us that they behave badly. So if the vaccination picks up very fast and greater percentage of people are vaccinated, the evolution of the mutants would be delayed. So my curiosity is, how much time do we have before we get another major hit, like what happened in April and May, which was pretty bad in India?
Yeah. Well, I mean, I wish I could tell you that it's not going to happen, but the reality is, I think it's to prepare for the worst and hope for the best. And, I think the only thing would be to really, continue with that vaccine rollout as fast as you can, because as you see here, this virus won't let up. It doesn't care that it's a third wave or fourth wave or it's a fifth wave, and it's summertime and it's time to go back to school, or things like this. So, I hope it doesn't happen for you guys. It was so bad for you. But I can't be optimistic either, and unless, the percentage of vaccinations increases.
I had understood Israel succeeded in vaccinating much better than most other countries and achieved a greater percent of population. Have there been fewer variants there? And has there been a slower appearance of the variants in Israel?
Yeah, that's a good question. I go to the map of Israel. It's, it seems to be not as, reported, at least, as hit hard. So I think for now, it seems to have worked very well. and we will have to see how long that lasts. But I haven't seen that in the news that it's basically broken through in Israel.
Yeah, Prem Kumar, you have a question?
Yeah, good evening, Sridhar, Paul, and all. Actually, a few observations and one question to me. Is it the erratic, Paul, is it the erratic human behavior or the inherent genomic instability of this virus that is driving these mutations? Or both?
I think it's both, I think the virus is adept at mutating quite quickly. And I think when you have these pools of human behavior that have sort of, neglected or, sort of not respected the transmissibility of this, it's sort of the perfect combination that the virus likes, And so I think it's a combination of both. Why
the virus is becoming fitter and fitter day by day, rather than, why is it so? Why can't it, downregulate its strength?
Yeah, I think,
not weakening.
I think when you look at it, it's sort of there is some pressure that must be felt by the virus, because if it was really, really left unchecked, it shouldn't become more fit. It shouldn't become fitter, but it is. So there must be some selection pressure on it, whether it's because it is infecting people who already have some natural immunity, but it's not good enough, and they get reinfected and they don't really know. Because remember, most of these, and it's interesting to see, because how many of Delta are actually asymptomatic. Before we knew that the majority of transmission, like almost over 50% of transmission for the parent virus, were asymptomatic transmission, right? And the least were the ones who were hospitalized and had severe disease, the least transmissible. So I don't imagine that Delta is any different. I think it's even more transmissible, and there's probably a lot more asymptomatic transmission. And I think it may be been occurring in people who have second infections and don't realize it, because there has to be some selection pressure for this to become fitter. I mean, that's just how viruses and Mother Nature works. You kind of back things into a corner in a way, and they get stronger. So there has to be some selection pressure. I mean, that's how all these infections work with bacteria and antibiotics and viruses as well. So I don't think we know exactly why, but it is becoming fitter. And there has to be an explanation that probably has to do with some selection pressure.
Paul, one more question. Inefficient vaccination. I mean to say the slow rates and not in a real quick time. Do you believe that it also exerts some selection pressure to evolve some of the mutations?
Yeah, I think you're right. So you're referring to, let's say somebody just gets one dose of the vaccine and not both. I think what we see with that data, which I was shocked by, is that really one dose of the vaccine offers nil, or essentially it's useless. It doesn't offer much protection at all. But there's still antibodies there, and remember, you have other parts of your immune system like the T cell response, et cetera. But most of that doesn't have much to do with the neutralizing antibodies that are formed. So if you have one dose of the vaccine, it's almost like you have given someone a low inoculum of these neutralizing antibodies that the virus can evade but still get exposed to, that would select out for mutations. It's sort of like low level. I just think about it as antibiotics. If you don't give high enough dosages, right? You have low dose antibiotics, or it's close to the MIC. We see it a lot with Pseudomonas. It'll just evolve, and all of a sudden you'll have that resistant strain. And I think there might be a factor where you have people who've only gotten one dose of the vaccine, and they have antibodies. They have some, antibodies present, but the virus can rage through it, get exposed to it, and it selects out for a fitter virus.
My finally one observation, and I need your comment also. Recently, I have gone through a Public Health England communication that's published on 25th of June, where it said the Delta variant in UK
all the CT numbers, the cycle threshold numbers are
Yeah.
less than 20. So
Oh, yeah, I believe
the
that,
viral
yeah.
load is more. And
Yes.
the doubling time is the spread is more observed in Indian and Pakistani ethnicities. And surprisingly, the fatality is less when compared to the case fatality rates are less compared to the alpha. It is only 0.9 when compared to 1.9 to 2.9 of the alpha. Do you agree with this observation that the delta's case fatality is less than alpha?
Well, I think it's certainly, I think the fatality was extremely high with you guys. I think there is going to be a genetic component to this where you see different genetics of population that are affected differently. You know, I think the UK and, you know, Caucasian sort of genetics overall seem to do better with this virus since day one. So I think there's definitely going to be a genetic, you know, sort of benefit, so to speak, in that, you know, and we've seen that the whole time with this virus, and that, you know, especially where we are, African American, Latinos just did worse, 4 times worse, you know, than Caucasian. So I guess that part doesn't surprise me too much, but I think the cycle threshold completely fits in that, you know, that's the amount of times you need to amplify the virus when you're doing PCR. So the lower the threshold means that the higher amount of virus there is, meaning you need to amplify it less time to you know, identify the virus. So when you have a low cycle threshold, it basically implies very high viral loads. So less than 20, excuse me, less than 20, less than 15 would be, you know, very high viral loads. And, you know, we use less than 30 where we are, but that definitely fits with the transmissibility and the higher viral load that you're seeing. But I think with the mortality, yeah, I do, you know, it's most likely because of that genetic, you know, sort of variants that you saw, especially with even the parent, you know, SARS-CoV-2. It just affected different populations differently.
Thank you, Paul and Sridhar, Raman.
Yeah.
Thank you so much.
Yeah.
So, Paul, one of the questions Dr. Naveen asked, that in the UK study, if you recall, they said 1 dose produces 70% of antibodies. But the more recent Nature article that you said, 1 dose was not providing any protection. Is the UK study not involved Delta variants? Is that why that 70% was effective, and now you're dealing with Delta and this 1 dose?
Yeah, I think exactly, because now is that I think that when that study was done, it just wasn't the predominant variant at the time. So now, but if they did it again now, they would, because the UK is also about 95% Delta, as is Scotland. So, you know, I think we have to see, this is just one study, the Nature one also, and it was comparing, you know, serum. I think, you know, more studies need to be done, but, you know, so we'll see. It might be somewhere it meets in the middle, where maybe 1 dose isn't just completely useless, but it's like, let's say 30% or something to that degree. But I think the bottom line is that we shouldn't rest our laurels on vaccinating with 1 dose. You know, it's basically to get both doses in everyone as soon as possible.
Yeah. So the UK strategy, which is not the strategy anymore, was to space out the 2 vaccine shots. India was forced to do the same because of shortage of vaccine. Do you think this is wise in the presence of Delta and the most recent Nature article?
No, I don't. Yeah, I think with this data, it's basically get 2 doses in as soon as possible. And I think doubly so, no pun intended, because there is that selection pressure, which, you know, I would love to hear a virologist, you know, an epidemiologist comment on that, but essentially that that basically the 1 dose might not be enough to obviously inhibit the virus at all, but it'll be enough that basically the virus would be able to you know, to sort of have that selection pressure and become fitter, you know, against the vaccine.
And can you comment, you did comment briefly on it, but as these variants are emerging, have you noticed that, firstly, I think we all agree they're a lot more transmissible, but are you also beginning to see more morbidity and mortality? I mean, are you seeing that now? Is the data supporting the newer variants becoming more virulent and death rates rising?
Yeah, I mean, that's basically the only article we have is what we're seeing here with the Scotland article in the Lancet. But you know, I think from what we saw from, and I think you guys from your personal experience would probably agree that it was quite devastating, and the death rate was quite high. And I think it's obviously the numbers that are being reported are underestimated. I think a lot of the you know, like WHO and other agencies are saying that the numbers out of India, the death rate was actually much higher. So I would actually like to hear, I personally believe, yes, that it is lethal, more lethal, and the hospitalizations will be higher. But I would like to hear from you guys about what symptoms you had seen, and also, you know, compared to the first wave, how this wave, which, you know, was obviously horrifying, compared.
Yeah. We can ask them, but can you go ahead and answer one other question, and then I'll ask Dr.
Sure.
his experience. What about, you said in one of your slides that the transmissibility is longer, you said, the shedding rate is higher, you said. So do you think we should still only isolate them for 10 days?
That's a good question. That is a good question. I honestly don't know. I mean, I'll be honest. I would say that it's something to make you think that we might have to look at that again. And certainly someone who's immunosuppressed, like we had mentioned the first time, someone who, there was the patient who was receiving you know, chemotherapy or chronic steroids, where they have persistent viremia and the virus was still fit, was still replicating, and the de novo mutated, you know, in the patient, you know, over a few, like 2 to 3 months. So, you know, that in those situations, I think it might be something that has to be looked at. You know, the question is 10 days versus 14 days. How long do you isolate them? Would it make much a difference? And the other question will be in what context. So if you're in the middle of a huge wave and everyone in the hospital is infected, you know, might not be as, you know, really necessary, because you're just trying to get beds, versus, you know, when things are sort of in the low point and you have these, you know, confirmed cases and you suspect it's a Delta, you know, would you want to isolate longer? You know, I would probably argue, yes, maybe, you know, if you have the luxury to do that, it might be a better idea. I don't really know how long, you know, 14 days versus 10, you know, that seems a little negligible to me, 4 days. But, you know, we've seen viral shedding go up to 3 and even 6 months have been reported. So, and those are dead viruses, though, by the way, usually. So the question is, you know, how long is it transmissible? And most of the time it's in patients whose immune system is blunted or they're suppressed for, you know, whichever reason.
So what do you think the role of immune modulatory therapy, which is being used without adherence to any protocol, do you think they somehow led to development of mutations, inappropriate use of steroids or tocilizumab or other ILK interleukin inhibitors?
Oh, you mean like tocilizumab and things like that? I don't think so. I think, you know, we're just playing catch up to what the virus does. I mean, when you're using those agents at that point, you're really dealing with the immune response and not the actual virus, so to speak. I mean, there is still viremia present, you know, although I think it's lower compared to the initial phase of the infection. But when you're dealing with that inflammatory response syndrome or the hypercoagulation, you know, I think that part of it isn't really responsible for the evolution of the variants. And like I said before, most of these hospitalized cases aren't what are transmitting. It's essentially the asymptomatic or the mildly symptomatic transmission that accounts for the majority of viral transmission. So I think
So-
as far as, yeah, go ahead.
In sorting out the 10 to 14 days isolation, would you think doing swabs on the 14th day, at least in some hospitalized patients, will give you some guidance? Because it's really an unknown thing right now for us. In
It
the
is.
US, we reduced it to 10 days, but our
Right.
infections are very low right now. But in
Right.
India, being as high as they were, do you think worth swabbing at least some people on day 14 is of any help?
I think it won't be helpful because you won't know if it's live virus or dead virus. I mean, you could still have positive PCR at day 14. Obviously, if the patient's symptomatic still, then you would maybe, think that was, actively shedding virus. But if someone's completely asymptomatic and you swab them at day 14 or 21 and they're still positive, that's unlikely to be, that's a recovered patient. And, I would say that's probably not someone who's infectious. But, I think we still have a lot to learn with the Delta and the other variants, and that could change. So we have to be very careful.
So,
Go with our intellectual guts,
Yeah. So, Dakar, you're going to start doing genotyping, I'm told, in King George Hospital. When will you start that?
Yeah, I mean, it has not yet arrived, but I have a question to Dr. Kelly on the same subject.
Yeah.
Like, what should be the strategy of genome sequencing? How should we do it? To how many patients? What are the different groups that we should do the genome sequencing? Obviously, we'll not be able to do for each and every one. Should we go? Yeah. Should we go by? Yeah, the disease severity, should we do the sequencing for all those who have the severe disease, or do we do for all those who are youngsters, or do we have any guidelines with that regard, or what do you think the percentage of people, the percentage of actually infected individuals that need to be sequenced?
So that is a good question. As far as I know, there aren't any sequencing guidelines. I think that at least for the New York State, for us, it's been a laborious task to try and ask for sequencing because they just do it randomly. Although now there is sort of a process. If we have a high suspicion for a variant, we can try and have that sequence. But I would say it makes sense to do it on the outpatient. You'd want to catch it before they're hospitalized because you can extrapolate that you're seeing a lot of outpatient, relatively mild symptom cases, or even asymptomatics, and you're sequencing those and their variants, that would actually tell you a lot more because then you would know really what's out there in the communities versus, just isolated in the hospital. And, you could probably just assume that the ones who are admitted are probably with the same thing. But if you knew in the community that there was a very high percentage of a certain variant, so I would say it makes sense to sequence if you're going to do dedicated sequencing to do it more in various outpatient settings. But I'd like to hear your thoughts about that. But that to me seems to make the most sense because really, when you're seeing the hospitalized, you're seeing the tip of the iceberg, and you really want to go for what's under the water. And I think that's really at the outpatient setting, because most people, will still have mild to moderate symptoms of this and not be hospitalized.
Would you genotype people who broke through vaccination 2 weeks after second?
Yes. Yeah, I think that would be also very good, a good population as well. Yeah. Certainly people with second infections, prior vaccination.
So Prem Kumar says that when they did look for in Delta after 9 days, they didn't really see PCRs being positive after 9 days culture. They did not see beyond 9 days. So, so why do you say that it sheds longer? I think in one of the slides you said it sheds longer. What was the base?
It was the increased viremia. I mean, I don't see much data on prolonged shedding. It's just that there's a higher viral load. So,
okay,
when you have a higher viral load, this sort of rate of that decline will be less than, slower.
Okay.
So you'd expect maybe to be more
can I come in, Sridhar?
Yeah, go ahead.
No, actually, that's not my question. Actually, in the first wave, initially we started isolating up to 14 days. And then, even after 14 days, if the RT-PCR is positive, we thought that the positivity is due to dead virus remnants. So
Right.
then they cultured it and no viability is seen beyond 9 days. That's why they made it to the day 10 for isolation. Now,
Yeah.
I propose that if the contagiousness of the Delta virus is longer, then why can't we do the same again? That is, culturing some of the, rather than RT-PCR repetition, which is useless, culturing the samples again under biosafety level for 3 or 4 and seeing the viability, whether it is still at day 9 or it's longer, so that we can have a relook at the isolation period. That's my question.
Yeah, no, I agree. I haven't seen that done or reported, but I agree. I think that that makes the most sense to see what the viability would be using cultures. Yeah.
There are very few labs in the world who could do coronavirus cultures, though. It's not like everyone can do this.
Yeah.
You have a level 4 lab to culture this virus.
Right.
Yeah. Okay. So, in terms of what are your main concerns right now, Paul, as we go forward, as it relates to any country? What should we
Right.
watch out for? And we pushed the vaccine, we got that. What else should we focus on?
I think we should really look for vaccine breakthrough infections and keep monitoring for those. Because yeah, we know that the vaccines will be effective, albeit slightly lower efficacy. But the real problem would be is if we start seeing infections with in patients who are vaccinated and vaccine breakthrough, because then then that would suggest you're dealing with escape mutants to polyclonal antibodies. So that would be the concern right now going forward, especially in countries who have high percentages of vaccination, such as ourselves, who are over 70% now in New York. If we start seeing a lot of breakthrough infections on vaccines, that would be very concerning.
So in India, where they primarily gave the AstraZeneca Covaxin and the Indian variant of a neutralized adenovirus, if the mRNA vaccines come, would you recommend they take it on top of AstraZeneca vaccine?
I think I think it would be something that eventually should be boosted. I think as this prolongs, there'll probably be it'll be necessary to receive boosters because the natural rate of decay of the antibodies, and it's different for everyone. We're seeing in our colleagues, and again, we don't know what the number if it correlates at all with infection, et cetera. But we are seeing a rate of decay. So I think the timing will be a factor. How long ago were you vaccinated? What's the percentage of virus ongoing in the community? And I think that we do know that the mRNA vaccines are across the board demonstrate higher efficacy compared to the adenovirus vaccine. So I think those would be situations that receiving a booster or receiving the series with the mRNA would be indicated. And certainly with the Sinovac, I mean, that one for sure, I would recommend vaccination even after getting that.
Well, can you comment on mixing vaccines?
As far as we're seeing, there doesn't seem to be any adverse effects aside from the usual vaccine side effects that people may have had or allergies. There doesn't seem to be, as far as we know, any concern with mixing vaccine.
Okay. And since India has so much of Delta right now, the next wave you think will it be Delta plus, or you think you will see more of the same before it all goes away?
That's a good question about how much infighting the virus will do. We don't really know much about Delta plus. You know, is it more infectious? The way this is going, you know, I can't imagine any variant now that is evolving would be less fit. So I think the fitness is just going to continue to increase. I mean, I hope I'm wrong, but it just doesn't make sense that it would not be the case. So I wouldn't be surprised if Delta plus, even though plus maybe is a misnomer and it's misleading because, you know, it sounds like it's more powerful, but, you know, I think all these variants and these mutations are starting to, you know, not all of them are always significant. So there's that. So that, you know, they have to be looked at as variants of concern, but the trend seems to be that, you know, they will continue to evolve to become fitter. So maybe not Delta plus, but maybe Delta plus plus will come, and that will be worse than Delta, you know. So it's certainly, you know, very concerning.
Yeah, Ram, you have any questions?
Yeah, I have a question for him. You may recall about 5 or 6 weeks ago when things were very bad,
Yeah.
somebody began to speculate that the next wave will hit children. And I remember you trying to answer that.
Mm-hmm.
There may not be anything special about children, but if there are so many unvaccinated adults around, yes, of course, children are not getting the vaccine and they will be vulnerable. So I was wondering if Paul had read the newer variants and Delta plus, similar to some changes, some differences in symptoms. Is there a greater attack rate in children?
No, that's a good question. I've been looking into that as well, because I actually am asked that a lot. You know, I have a daughter myself who's 5. So it seems that they're still evading it. I mean, you read these stories about, I mean, you probably have personal experience, you know, in India, you know, children who are basically orphans now because both parents have died. You know, we're not seeing an uptake in the multi-inflammatory syndrome that, you know, that it seems to be rare anyway, but there seems to not be an uptick in that as far as I've seen. There is a concern because of the infectiousness that it may affect the children or even, you know, younger adults, you know, age range 10 and above, 10 to 18, because they're certainly, you know, when we talk children, I'm talking age less than 10, but there's certainly been increased cases of, you know, young adults who are getting infected with this. You know, we'll say, you know, teenage years, 12 and 12 plus. So I think getting 12 years and plus vaccinated is important because there are higher rates of, you know, like I said, 70% of those cases did not have any comorbidities. And, you know, there wasn't commented about the age range, but, you know, I did see data that there was younger adults that are being affected by this as well. You know, whether or not it's due to, you know, their, you know, not taking precautions, but also just because it's a more transmissible virus variant, more transmissible virus, and also because it's predominantly transmitted through asymptomatic, which we saw previously with young adults. But as far as like age less than 10 and, you know, like multi-inflammatory syndromes, I have not read anything about upticks in that. I know in September there's going to be trials for ages 2 and above for vaccine. So we'll have to see. But as far as I know, and even my pediatric colleagues, and, you know, we haven't seen much on young children, age less than 10, really being affected by this. So I still think their ability to evade, whether it's their ACE2 receptor and their natural killer, robust immune cells, is still, you know, allows them to evade this. But, you know, I think for now, I haven't seen or read about that age group being affected more, but certainly young adults, yes.
Is it still true similarly in other countries where the problem is still heavy, like Brazil? Are there more children infected?
You know, honestly, I haven't read recently about Brazil, but so I can't comment on that. But I again, from what I was looking, I didn't see much about young children. becoming affected
Okay.
in places like that are hit with their own variants.
Thank you.
Yeah. I think India is also getting Pfizer vaccine, Naveen is commenting, and Zydovac for 12 years and older. I think India also is getting kid vaccine. I think the Delta variant from the All India Institute of Medical Sciences, what their data showed was the total number of sicker people was no different than any other variant, but the percentage of people who were sicker, who were below 55, was at least 25% higher than the previous variant. So it did affect younger people, younger meaning below 55, not necessarily kids, but that's what Delta did in India. So more younger people, if they died, actually higher number of younger people died, even though the total number of percentage of deaths was the same as the original virus. Any other comments? Anyone else have any questions? Sudhakar? I don't see. Yeah, go ahead, Sudhakar.
Hema Malini has raised her hand. Hema Malini.
Go ahead. Go ahead, please ask. Wherever you are, you have to unmute. We can't hear your question.
Take another question in the meantime. I'll go and find her. I know where she is.
Okay. Anyone else has any question?
Okay. Yeah. I have a very fundamental question as to how this transmissibility, we talk a lot about the transmissibility of the virus. How is it exactly calculated?
Sorry, could you repeat that? How's?
Yeah, we talk a lot about
more transmissible, 55% more efficient, you said. How do you actually calculate that?
I think they calculated it with the percent of patients per years, I think.
Okay.
Number, yeah.
So when you said 55%
rate per person, 100 years, per 100 person years. Oh no, that wasn't it. That was the hospitalization.
Okay. Dr. Hemalata, you could type your comment if you can't.
My question is, Dr. Chilamud, Dr. Kelly, on our infections or the vaccination trends in the United States and the new variants detected recently, what is the prediction? Like, is there anything that we have a forecast?
Well, I mean, I think what we're probably going to see is pockets of areas that are unvaccinated have, very high rates. As you can see here, in areas that are already under vaccinated, the Delta has taken over quite quickly. And I do expect some other pockets to increase here in the southern states where there's also, a lot of under vaccination. So the fact that it's almost doubled in 2 weeks is of grave concern. And I'm curious to see where we're at going into August. I don't expect it to go down though.
Can't end any meeting without talking about masks. Paul, what do you think about masks in India with 18% or so vaccination rates?
I think masks in large groups and in indoors still makes sense. I think, wearing masks outside, obviously not around others is fine, but I still think, in enclosed settings, masks should still be worn. They are shown to be protective. And I think with mass gatherings, and with a population or pool of people who you don't know if they're vaccinated or not, it still would be recommended.
Someone asked a question. Have you ever seen a reaction to methylprednisolone alone to the medication itself? Have you seen any reactions? I think Dr. Sudha may have. Do you have a case that you want to talk about, Dr. Sudha?
No.
No. Okay.
No.
Why are developing countries?
Oh, I was just going to bringing up, one of the things that was interesting that you guys experienced that was the increased number of mucormycoses, and predominantly they were in diabetic patients, and I think there was some theory that because of also the use of steroids as well. And I mean, I'm not sure if that explains everything, because we also have a high amount of diabetic patients, and we use steroids in all our COVID patients, and we really didn't see, as far as I knew, I think there was one mucor that happened after, it was a complication, but it was after the infection. And so, I think that's a phenomenon that hasn't really been explained too well, and I'm curious to hear the thoughts of the audience about that. But as far as direct adverse effects of methylprednisolone, no, I mean it's pretty good used in the acute setting, and we haven't seen adverse effects with it, but complications from it, I think the mucor thing seems to be sort of an unexplained phenomenon at the moment.
So the next question is, why are mutants developing more in developing countries and not in developed countries? I mean, what is unique about these populations? Or why are they starting there? South Africa, India, Peru. Why developing countries are more mutations are developed? Can you comment?
I mean, I think the statement, there was a UK variant, so that was a developed country. There's the New York, the California variant. I think it might take hold in more in places that the infrastructure, sort of been not allowing for the vaccinations, and transmissibility, and maybe the lockdowns ended early, which is what you saw in a lot of the South American countries and also in India, where they had very early lockdowns. That also happened in Peru and Chile and Brazil. And Brazil also became very political, sort of like the United States, where there wasn't a lot of regard for mask wearing and things like that. So I think there's other factors that play into some of these other countries. Africa is still an enigma to me, because it did very well so far, and there's sort of some terror in some of the scientists' articles that I read, that they're waiting for it to really explode in Africa, but you really haven't been seeing that, with the exception of the South African variant. So it's sort of interesting what's going on in that continent of Africa and why it hasn't really exploded as much in other parts of the world. Personally, I think it's interesting. We have a lot of Ghanaian travelers, a lot of travelers going to West Africa. I see every day, almost on a weekly basis, but even other days during the week, they're all traveling back and forth to visit family. And I haven't seen them scathed at all by this, to be honest. And we have a very mobile, West African population where we are. So I'm not sure how to explain it. It's actually pretty interesting. But I think it's not just underdeveloped countries. I mean, again, like I said, those examples, the UK, New York, California, which are sort of their own countries, develop their own variants. So, I think it's really to do with the population. And, we do know that there's a genetic predisposition for certain populations to do worse with this virus. And I think we can expect that to continue with these variants.
Dr. Naveen Kumar has raised his hand. Can we ask?
Go ahead, Naveen, ask. Go ahead. Naveen, you can unmute. You have to unmute, Naveen. We can't hear you. So in the meanwhile, you commented briefly about epsilon and lambda. What do we know? Is it more transmittable? Are they more virulent? Should we worry about them?
We don't know yet about lambda, which is the Peruvian one. Epsilon we do know, which is the California one, which is pretty ubiquitous now. It's in many countries. The transmissibility is high. It's not as high as Delta, but it has the 14G, so it's definitely high compared to the parent virus. And lambda, is something to watch. We have to see how that one will evolve. It's unknown at the point though.
Okay, so Naveen couldn't unmute, but we answered his question, Sudhakar.
Yeah.
Okay. Any other questions?
Yeah, I was hoping that the question I had posed about just your personal experience with the.
Yeah, let's ask them. Maybe Prem Kumar, Sudhakar. Tell us about, in terms of clinical presentation, how was Delta different than the original Italian version that you first saw? What was different? Is it headache, rhinorrhea? What was different? So something we want to watch out for from our end. Could you comment on that? Prem?
Yeah. Can I come in?
Yeah, please.
Yeah.
Yeah.
Actually, the second wave swept in like anything, huge number of cases, hospitalizations, but the mortality, whether it is increased or because of the huge number of patients, the mortality observed to be relatively increased. We don't know about it, but definitely high transmissibility and huge numbers of cases were admitted. And clinical presentation, in the previous waves, we had a lot of asymptomatic infections, but this time the asymptomatic infections were a little, less. How I know is earlier some people, they used to say in a family, if one person is symptomatic and got the RT-PCR positive, when we tested all other family members, they were positive. A few people were positive, 2 or 3 in the family, but they remained asymptomatic. That was in the alpha variant or the initial first variant. And then now in the second wave, initially we really didn't know that it is, Delta, but once the wave is over, then the results came in and we came to know that it was Delta. And this time, the household contact secondary attack rate was very high. Almost all the family members, they developed RT-PCR positive as well as symptoms. And majority of the people, they developed fever and myalgias. Those things were a little severe. And in the second wave, the Delta wave, earlier we thought that pneumonia onset is, if you think about the timeline of the coronavirus disease spectrum, earlier we thought that the pneumonia onset would be on the day 8 and ARDS would be on day 10 or 11. But in the second wave, that's with the Delta, the onset of pneumonia and ARDS was a little earlier, that is on day 5, day 6. Right. These were my observations.
Yeah, that's striking. That's striking to hear. I do remember you saying that too last time.
Yeah,
that's definitely striking to hear.
So there's a question about post-COVID diarrhea in patient diarrhea. How do you manage diarrhea in a post-COVID patient? Let me take a stab at it since I'm in gastroenterology. There is a acute diarrhea that happens with acute COVID. We know very well about that. 40% of patients will experience some GI symptoms, and quite a few of them will get acute diarrhea, but it's very self-limited and resolves fairly quickly. Some people use zinc for it. If you want to use it, don't exceed 25 milligrams a day, because I think the 50 milligrams is too much. It causes nausea, and there's no evidence that 50 is any better than 25. There's no evidence actually even 25 is of any value in this diarrhea. In the post-COVID, this is, I'm assuming, subsequently people developing diarrhea. I think they'll fall into a category. One is the more dangerous one, which will be the multi-inflammatory system syndrome, where diarrhea could be one of the presentations, along with myocarditis and other syndromes, hypercoagulism, things like that. The second one that we observed, which we wrote about, is that some patients develop transient pancreatic insufficiency with post-COVID syndrome. So we gave them pancreatic enzyme supplements, and we had 3 patients whose symptoms completely resolved after that. There's a third group that we are struggling with, where they have this persistent diarrhea with weight loss and malabsorption also to some extent. This anecdotally, people said vaccinating them actually made them better. So I've given it to 2 patients, vaccinated them completely, and did not see any resolution of symptoms. So there, I think there is this unknown group of patients who get prolonged diarrhea and weight loss as a post-COVID manifestation, which we don't know what it is and how to manage that. When we did colonoscopy and biopsied them, the colonic biopsy showed mild inflammatory cells, like somebody like a microscopic colitis kind of picture on biopsy. We didn't look for viral particles in it, but we've seen it. And so we don't know what to do with them either. We're just monitoring them. Some of them resolved. Some patients, it still persisted. So those are my comments about chronic diarrhea in some patients as a manifestation of post-COVID. I think if they are part of multi-inflammatory syndrome, obviously steroids and immunoglobulins are useful. If you can define them to be because of pancreatic insufficiency, you could give pancreatic enzyme supplements and see what happens. And the last group, where we really don't know what is happening, I can't recommend any particular therapy for them at this time. I think we need more information what to do with them. Paul, there's some evidence that some of them may actually, all these widely used antibiotics quite for no reason, may cause some C. diff and antibiotic-associated diarrhea. That always is something to look for. Paul, anything else you want to add about this particular problem?
No, I mean, that was pretty comprehensive. I mean, I guess the only thing would be also in the endemic to your area is also, I know with strongyloides and using ivermectin, treating for any parasitic infections, but which could be exacerbated by the administration of steroids.
Yeah. Okay. Any other?
Yeah, Sridhar, one last doubt for.
Yeah, go ahead.
Paul, actually, those people, at least a few people after vaccination, they are coming to us and say, our antibodies, we didn't develop antibodies, so how we are protected? Then we say, look, at least your T cell immunity is there, and that will protect
right.
you. Is there any way to measure how much of T cell immunity he developed, or is there any way to measure it, like assessing the interferon gamma, or if at all the T cell immunity is there, how long it persists? Is it for decades or what?
That's a very good question. So, there's no routine, way to measure like a quantiferon test, for example. But I know there is data that, and I had presented this last time, that the T cell response is uninhibited, or it's unaffected by the variants. So the T cell response will be potent regardless of the variant. So it's also something to rely on in addition to the vaccines. but certainly not enough to rely on alone. But it seems that there isn't any, as far as we see now, any effect on blunting of the T cell response with these variants. So the T cell response is certainly a factor, and I had presented that data last time that they did look at that, and they didn't look at delta, but they looked at alpha, beta, and gamma, and they showed that there was really no effect of the variants on the T cell response. They all were affected by the T cell. As far as how long it lasts, I mean, they're not your memory B cells, so with immunology, it's only going to be during the acute infection, and protection after that really isn't going to be offered by the T cells. So it's really just during the acute infection.
So
now,
Prem, you could answer this question. How do you manage a post-COVID persistent cough?
Well, we are seeing quite a number of cases of post-COVID cough. Reasons may be so many. One common thing, what we are seeing is interstitial pulmonary parenchymal fibrosis. We are seeing a lot of cases of pulmonary fibrosis due to the extensive onslaught. That is one. And upper airway cough syndrome. Some people are having, chronic, itchy, irritating cough in the throat. So right now, if there is no pulmonary cause, and if only itchy, scratchy upper airway cough, we are giving, antihistaminic, decongestant, and cough syrup containing codeine. The antihistaminic, decongestant, and I use only half doses of decongestant. Phenylephrine 10 mg, I am using half, but still the decongestant effect is good, and not concerned about hypertension or anything. That's about the upper airway cough syndrome. Coming to the pulmonary parenchymal fibrosis, it's real difficult to answer this because people, they're keeping on coughing. And recently I had attended one case where, patient is on NIV for the last 90 days and still she is coughing a lot. And during cough, the saturations are dropping, and again, she's coming back to the saturations. So we tried everything, codeine, dextromethorphan, gabapentin, the gabapentin, everything. And in the literature, they said thalidomide is also having something. So even a brief course of steroids are also not working on it. Probably that's a persistent cough as far as this interstitial lung disease is concerned. So going along with the PINSAR trial, we are, some people here are trying pirfenidone and nintedanib to address the root cause of the cough. But I am personally trying nintedanib. I have tried more than 50 cases so far from the first wave, and it's showing improvement. The problem is whether the resolution is due to nintedanib or spontaneously that I have to do it. We have to leave some cases not giving nintedanib and some cases giving nintedanib, and then see whether it is due to nintedanib or just a placebo effect or just because of the time they have all resolved. This is my experience with time as far as cough is concerned.
And in those cases with fibrosis, are you seeing resolution on CT scan, like at 3 months of the changes, or are they persisting?
Yeah, majority of the, depending upon the initial onslaught, in the initial acute phase, if the lesions are minimal, like, less than half of the involvement, usually that means less than 12/25 score as far as the, the
Right.
profusion score. Usually they are coming off by, third month, but beyond half of the lung field involvement, usually it is taking up to 6 months. And even up to 6 months, at least 10 of my patients are still on oxygen concentrators, and few of them even recommended for, transplant. Recently, one young guy who was on ventilator, tracheostomy for, 108 days, he was referred to Hyderabad KIMS for transplant. So this is how we are proceeding.
Yeah.
Yeah, thank you.
Okay, Sudhakar, I think
Yeah.
we took all the questions that are. So
Yeah.
go ahead.
Yeah. Thank you very much, Dr. Paul Kelly, for a wonderful presentation as well as answering all those questions. And it was really a very wonderful brainstorming session that we had today. And thank you, Sridhar, for enlightening all of us on the various aspects of this variants and taking up the questions as well. And Dr. Ram Kairam and Dr. Prem for chipping in and answering all the questions, and Dr. Ram Mohan for those wonderful questions, which have really made a lot of difference, and it made us to think. And all those people who have posed the questions and for your wonderful interaction, I thank you all very much. And next week again, we will have a session at the same time. And until then, bye-bye.
Thank you very much.
Thank you, Paul.
Yeah, very
Thank
much.
you,
My
Prem.
pleasure.
Yeah, good night.
Thank you for your
Sridhar, Ram,
input.
and good
Okay.
morning.
Thank you, everyone. Be safe. Yeah.
Bye-bye.
Thank you, Sudhakar sir. Thank you, sir.
Bye-bye.
Bye. Bye. Sir.